Greetings. In this series, we are going to look at mathematics from around the world. Math is a subject that is studied around the world by various peoples and has involvement in culture at various levels. We have images used as artwork from geometry, and we have geometries that were studied because someone was looking for one thing, discovered another, and then that was applied to something else. In this series, we want to look at mathematics from around the world and the various things that connect us as a people in a beautiful creation. I hope you enjoy worldwide mathematics. In this episode, our focus is on Brazil, and specifically we are focusing on the mathematician Julio Cesar de Mello e Souza, who is also known by his pen name Malba Tahan. He is a pioneer of ethnomathematics in Brazil. And if you don't know what ethnomathematics is, I'm going to give you a bit of a brief idea as conveyed by a website who is reconveying information that first appeared in the journal The Teaching of Children in Mathematics. This is not the particular issue, but this is the journal in which they quote. And in it they quote some information in the idea of ethnomathematics being something that expresses the relationship between the cultural identity and mathematics. And a couple of books that our feature mathematician has published, their English translations of the titles are Numerology, Know Your Destiny by the Numbers, and The Animal Game in the Light of Mathematics. Both of these were published in Portuguese. The second one was published posthumously in 1974. There is a National Mathematics Day in Brazil. It occurs on the 6th of May, which is the mathematician's birthday. I am going to talk about a challenge problem that appears in one of his books, whose English translation of the title is Fun and Curious Mathematics. This provides a mix of various interesting problems. It conveys the crow discussion about the ability of crows to be able to count, which also appears in Professor Devlin's book. So this is kind of a known phenomenon that some animals seem to have the ability to count. But the challenge problem that we're going to look at, a problem that deals with setting a compass to a certain width, and then with just that single width, being able to create more than one circle. And so we're going to look at that challenge problem. The first circle that we are going to do is just the typical one where we put a circle on a piece of paper using the compass. And so I've just drawn a point already. I'm going to place the point of my compass on here, and then I'm going to just use the scribe portion of the compass to create a circle. All right, and so now we have this circle. Its radius is the setting on our compass. So now how can we use this same setting and create a circle that is not congruent to this circle? Well, the thing that we're going to do is we're actually going to change geometries. So right now we are in the plane, or the Euclidean geometry, in 2 dimensions. And we are going to move to a different geometric space. We are going to move into elliptic space, And specifically, we are going to look at a sphere. And so now when I use my compass with the same setting, if I put the point on the sphere, I move from the tangent setting that I have, and it's going to rotate down so that it can meet the sphere. And then when we draw this circle, we create a circle on the surface of the sphere. Now we have two circles, and we can demonstrate that these two circles are not the same either by measuring directly or cutting this circle out and placing it over the sphere. I've taken a marker and I've highlighted the circle that we've created on the sphere, and I've also cut out the circle that we created in the plane, and we are going to just show that we can set one on top of the other. And so we find that the circumference here and the circumference here are not lining up all the way around the sphere, showing that this one on the sphere is actually a smaller circle than the one that we've drawn in the plane. Now, this is not a great circle on the sphere here, but it is circular in nature and use the same setting on our compass. So where else do you think we might be able to apply our compass to get a different circle? Well, one of the solutions that our professor has demonstrated in his book is that if you set the point of your compass on the top of a cone, and then you will move from the tangent and the plane, and you will have to rotate down on that as well. Similar in the way that we rotated down on the sphere here, we will draw a circle around the top of the cone, creating essentially a smaller cone, but the base of that smaller cone is a circle. And that circle can be different than the one that we drew in the plane here. We could try other objects as well. If you have something like an odd-shaped object, like this candle, we might try to fix the compass point in here somewhere, and then this is going to rotate from the tangent into here somewhere, and it will create a circle also. In this case, it interestingly falls kind of in this groove that's already in the top of the candle. And so we can, again, use our plane and show that it drops well over the top portion of this candle, and so we've created another circle. So I believe this is a circle, again, that is different from the one that we had on the sphere. So we've demonstrated three here in front of you. One of Professor de Mello y Souza in his book is the cone, and perhaps you can think of others. I hope you've enjoyed this look at this geometry challenge, and I hope you have found it interesting to learn about Professor Julio Cesar de Mello y Souza. Keep exploring the mathematics and the world around you, and enjoy that ability that you have been blessed with to do this. Cheerful Calculations.